Hi, welcome to Cainers Commodore Capers. This is episode number 3. So far we've looked at a 1541 and a Commodore 64, but today I'm going to be looking at this fantastic Commodore 128. These are an absolute feat of Commodore engineering, and I think Commodore at their best. I mean, who else could cram a Z80 and an 8500 processor into one of these boxes? Completely different architectures, completely fantastic piece of kit. Does 40 and 80 column modes, emulates 99.9% of Commodore 64. This one's got shipped over. I got shipped over from Germany. Guy there was having a few problems with it. Decided to buy it off him just to see if we can get it going. So we're going to have a look at this today. This one has had a little bit of abuse. I don't know if you can see there. You've got a couple of screws which somebody's put through the bits at the top here. This is also a German model, so we've got various different symbols on the keyboard than you would have from a standard UK or US one. Most of the keys are standard though, but these are, I believe, are ASCII and DIN, slightly different. So we're going to have a look at this. We'll have a look at the keyboard a bit later. There's also on the side here a switch. Not entirely sure what that's for, but at the moment when we turn it on, all we're getting is a black screen. So I'm going to just switch it on there. And as you can see, all we're getting there is just a black screen, nothing on it. Okay, just going to try moving that switch, just in case it's some sort of ROM switch or something like that. Nope, still got a black screen. We'll just move that to one side as well. Move it to the other side, see what we get. Nothing at all. Okay, so we've got the 128 completely dead, no display, nothing at all, no power light, which is interesting. Don't know if you can see them when we switch it on. Get no power light at all, just here, nothing there at all. But there's obviously something happening because we're getting a black display. So I think what we'll do is we'll whip it apart, have a look, and see where we get to. So keyboard off, you can automatically see here, well you may not be able to see, let's spin that around. Okay, you've got some sort of custom ROM here, which is where the 128 ROM normally sits. So we've also got a custom ROM here. So as I suspected, that switch there that runs right the way around there, that's normally some sort of toggle as to what type of ROM we've got in there and what somebody else has looked to fit in there. That's got a Commodore marking on it, so that just may be an original factory thing. But we'll get the silver case off and have a look. Okay, now usually this one's obviously been off a few times before. Normally you can see here in these clips they actually secure the top of the lid. They're little bent metal clips, and they normally secure this frame to the top, which is part of the shielding. And they normally secure it to the top, but it's obviously been off a few times before. So let's have a see what we've got. Okay, interesting. I've seen a couple like this before, and I must admit I got taken to church by one of them. Sent off on a wild goose chase, changing all sorts of stuff. In actual fact, what happens is when you power these up, the Z80, which is this piece of this processor here, that's in charge first of all. That starts the machine up, executes a small piece of code, and then throws control over to the 8502 here, which then starts the machine up. What we're going to do is have a quick look and we'll see what the address bus is like on the RAM, just to see if there's anything happening whatsoever. Okay, now you can see that the pattern there on the scope, the pattern is continuous, which means the data bus isn't doing anything. There's nothing happening at all, it's just going round and round in circles. Okay, you can see it's pretty static, not a lot going on there at all. I'm just going through the RAM, pinning out pin 2, which is the data out. There we go, just going round and round in circles, executing the same thing over again. Just completely, whilst there's a clock, so that means you've actually got a data bus, there's a clock being supplied to the 8502 processor. There was a clock being provided somewhere, which is always good news. Nothing is happening. I've just turned it off again, I'm just going to power it up. Okay, so you can see there, nothing is happening. Now, what we're going to do is, because there's nothing happening at all, we're going to concentrate our investigations on the Z80 here, and we're going to concentrate and make sure that's getting a clock, make sure it's starting up properly. Now, we know that, or I know rather, that the Z80 is the first thing that's in control of the 128 when it starts up. We've seen that there's bus activity on the RAM, which means there probably are clocks, and the clocks are working, which feed other parts of the 128, they're working okay. What we really need to check is to make sure that this bad boy is behaving itself. We'll have a look at the address bus, see if there's any activity. We'll have a look at the data bus, see if there's any activity on there. We'll also check that to make sure that the Z80 is getting clock. Again, that's quite important to make sure it gets that clock, otherwise the Z80 won't do anything. So I've dropped the circuit diagram down a bit for you. This line here is the one which is the Z80 clock line. That one there, which you can see comes down there, scrolls along here, and then is fed out of a 7407. I'm assuming they've used these in order to make the clock a little bit stronger for the Z80. You've got a circuit here which you've actually got an input on 11 and 13 of the U60. Now, I'm not a logic expert, so I don't actually know why they've got that fed in like that. Maybe it's just to make it stronger, I'm really not sure. However, what we'll be checking is 13 and 11, which are the inputs to U60, which is the 7407. We'll be checking those two. We'll be making sure there's an output, and if there's not an output, we'll be checking these two resistors. Because the 7407 is open collector, and the outputs need to be pulled high in order for them to work. If there's no upper voltage pull, they won't work properly. So what we'll do is we're going to check these. Okay, we're going to check the inputs 13 and 11. We'll have a look at the outputs, make sure there's something happening, and we'll also make sure that that clock is being driven, the Z80 is being driven. Having had a look at the circuit diagram, we know where the clock comes from. We're going to have a look at pins 11 and 13 to make sure there's an input on the 7407 here. We'll also make sure there's an output on pins 12 and 10. So going back, we'll have 14, 13. Okay, let's see if I can crank the time base up there. There you go, you can see we've got an input on 13. Next pin to have a look at is 11. Okay, you can also see we've got an input on 11, so make sure to see if we've got an output on 10 and 12. I'm not expecting much. Nothing on 10, 14, 13, and nothing on 12. So we've got nothing coming out of here. Now, as I said, what we'll do next is we're just going to have a look at the voltages at the top of the pull-up resistors, which is R35 and R45, which should be 12 volts and 5 volts respectively. So we'll have a look here. Now, one of these should be at 5. Okay, let's crank that down. Okay, so you can see at R35, at the top of R35, we've got 5 volts. If we look at R45, we've got nothing on that side, nothing on that side. So we've got no 12 volt supply to that resistor. So then we have to have a look. So having ascertained we've got no 12 volt supply, there's no way that that circuit's going to work because we're missing that supply. So we need to find out and have a little look back and find out where the 12 volt comes in. Here's the actual voltage regulator circuit. This is the area where the 128 generates its 12 volts. Now 5 volt is supplied natively from the power supply. What the 128 does is there's 9 volt AC which comes in, which gets rectified by the bridge rectifier here, and then gets smoothed out by these two caps. That voltage is then passed to the 7812, which is a 12 volt positive voltage regulator. It's a 1 amp one. Now it's not heat sunk, which means there's not a lot of current drawn from it, so it doesn't get too hot. But we'll have a look and see if there's anything, see if there's any volts actually going in and coming out of that. So I'm going to put my meter here. So I'm going to put the negative on the ground there. It's just any ground on the any point of ground on the 128. I'm going to put my other probe on there, power it up. Okay, so you can see we've got 24 volts going in. Okay, the middle pin is ground, so we'll have no volts there. On the other side. Okay, so we know that we've got a 12 volt supply coming out of the 7812, but there's nothing down here on the resistor. This is the resistor we're looking at. Now, what I've had to do is just trace that back, and it's not always easy, but I believe it's this one that creeps up the inside there and whizzes up the top here. I should pull this down a bit so you can hopefully see. And if you follow that line all the way up, it actually comes to this one here, this little through plate here, which I've desoldered. Through there, that is actually connected to that. There's a line there which goes through onto that, which goes to the bottom of C86, and then around the bottom of that, it's actually hooking in to the pin 28 of the 6581, which is the 12 volt supply. Now we've got continuity between the top of R45 and there, which I've already beeped out, so we can go from there to there, and if we follow that track through. You can actually see that it goes to here. Now, I don't know whether you can spot it, but you might see some slight corrosion on those 3 tracks. Okay, now then that again is another through plate which hops underneath the board on the other side and actually bridges across to the 12 volt regulator. If you look here now, you can see how badly corroded those are. And there's around the top you've got all these silver markings, which is where the PCB track actually meets and goes to the through port. It's completely gone, so there's no top. It's completely corroded away. There's no top there at all, so I think we're probably going to have to rewire or trace where they go to and make sure we can sort of get into them further down the line and figure out where they go to. We'll have to rewire those 3 and then hopefully that'll bring the thing back to life. Okay, first of all we're going to repair the 12 volt link. Alright, so this through plate here, which is the 12 volt one on the other side, I know will link to pin 28. So if we do a wire link between there and pin 28 on the SID at the top there, that'll make that 12 volt line live. We'll trace out where the other 2 go in a second, but let's get that one live for the moment. I've got some PCB repair wire here. I'm going to stick the pin through that hole. A bit of solder on there just to make sure it's taken as neatly as possible. Going to run that through there. Try and get it so you can see what I'm doing. I'm going to run that through to there. Snip that off. Try and get it to the length that we need. Just trim the end off. Not very pretty repair this one, but it'll do the job. Just move that round and just persuade that to go around there and hook it in. That'll make it easier for us to solder and cut so you can just run a piece of PCB repair wire from that through plate there to pin 28 of the SID. Okay, so we should now have continuity between the 12 volt and the SID. That's the plan. So if I on there, other side of the 12 volt regulator, there we go, continuity, and I'm going to check down on the resistors, and we've got 12 volt there. So that's the 12 volt one fixed, which is always good news. Right, so having done those track repairs, I'm just going to switch it on, see if it works. fantastic. Love bringing these things back to life. That was a fairly simple one. Just took a little bit of looking at, but again, it's always best to check the basics. Always find out, you know, what's going on. Have a look at the voltages. Always check them first. Make sure you've got everything everywhere. As you can see, just a simple not having 12 volts in a particular place brought the thing to its knees because the Z80 didn't get a clock.